So we're going to have a quick look at balancing equations. It's one of the basic aspects of GCSE Chemistry, but one that can often give students a few problems. Let's have a quick look at the start. So if you consider a reaction where we got two reactants on the left hand side and they don't equal, they produce some products. Key thing to consider is however many atoms in total you start with on the left hand side, you have to produce exactly the same number of atoms on the right hand side. That's the whole point of balancing equations. You can't start off with atoms and then they just disappear, and you can't create atoms that you didn't have to begin with. That's a bit random in a general equation, so let's have a look at a specific example and see if that helps. So here we're looking at the reaction of magnesium with oxygen. The first crucial thing to remember is that oxygen doesn't go around on its own, it has to go around in pairs, and we draw that like this. The second thing to consider is what's made. In this case it's fairly easy. Magnesium plus oxygen produces magnesium oxide, which is MgO. Or is it MgO2? Or is it Mg2O? If you remember from your work with a valency table, you need to do a little trick to help you remember that. I'm going to do that in blue over here. Magnesium is in group 2, so its valency is +2. Oxygen is in group 6, so its valency is -2. The tip that I tell my students is ignore the signs, swap them over, drop them down, simplify. So let's have a go with that. If I ignore the signs, I write Mg2, and ignore the signs for the oxygen, it's O2. I've ignored the plus, I've ignored the minus, I've ignored the signs. I swap them over. Well, if I swap them over, it's actually exactly the same. The 2 here goes across here, and the number here goes across here. Drop them down, whoops, I've snuck in ahead, 2. You then drop them down, Mg2, O2, and then you simplify. It's a bit like maths. When you've got a 2:2 ratio here, it's equivalent to a 1:1 ratio. So what we're saying is, when we've got magnesium reacting with oxygen to form magnesium oxide, if we do this trick of ignore the signs, swap them over, drop them down, and simplify, this is the formula of magnesium oxide. We cannot change it. So this formula here is something that we are unable to change. Let's have a look at what that looks like in terms of atoms now. Here we've got magnesium, and it's a magnesium atom on its own. Here we've got oxygen, but it's bonded onto another oxygen. And we make magnesium oxide, which pictorially can be represented like this. How many magnesiums have we got to begin with? We've got 1. We produce 1 magnesium, so this magnesium here turns into this magnesium here. It's balanced in terms of magnesiums. We start off with 2 oxygen atoms, but we only produce 1 oxygen atom. We could write an extra oxygen here, but remember, when we react magnesium with oxygen, we only produce 1 product, and it's only magnesium oxide. If we've got an oxygen spare here, let me draw it in. Here it is. The only thing that oxygen can be bonded to, because there's only 1 product, remember, is magnesium. So in fact we produce 2 magnesium oxides. That must mean if we've got 2 magnesium here, we must start off with 2 magnesiums here. So let's just check. 2 magnesiums to begin with, 2 magnesiums to finish with, 2 oxygens to begin with, 2 oxygens to finish with. How do we show that in our balanced equation? Well, we write 2 magnesiums plus oxygen produces 2 magnesium oxide. And that's our finished balanced equation. We'll have a look at one more example and see how you get on with that one. Here's my next equation. So we've got methane. I'll tell you the formula of methane. It's CH4. You're not allowed to change the formula of methane. Remember, oxygen goes around in pairs. You should know that carbon dioxide is CO2, and I hope you know water is H2O. Let's just draw those, see what they look like, and hopefully we can do some adding up. There's methane, CH4, reacting with oxygen. Remember, oxygen goes around in pairs, O2, and that produces carbon dioxide, CO2. and water H2O. Let's just add up atoms and see how we go. On the left hand side we've got one carbon, no other carbons here. On the right hand side we've only got one carbon. So the carbons balance. This carbon becomes this one carbon. Here you can see we've got 4 hydrogens. Down here, 4 hydrogens. We've only got 2 hydrogens here. That must mean we produce more water. We don't produce hydrogen as an extra product here. We only produce carbon dioxide and water. The only product that contains our hydrogen is water. So we produce more of this. More water. Okay? 4 hydrogens here. Now 1, 2, 3, 4 hydrogens here. So the carbons, 1 carbon, 4 hydrogens, 4 hydrogens. On the left hand side we've got 2 oxygens. On the right hand side we've got 1, 2, 3, 4 oxygens. That must mean that we start off with 4 oxygens. Those are my 4 oxygens. So in terms of balancing it, we've got 1 methane. We can write a 1 here, but we tend to ignore it. We start off with 2 O2s. We produce 1 carbon dioxide and 2 waters. So this is my final balanced equation. Hopefully that's helped a little bit.